Okay dear student, now in this video we will discuss some of the useful points to prove that the given points on the Cartesian plane are of square or rectangle or of parallelogram or of different types of triangle. So for that we will revise a bit about the quadrilateral concept that we have done in standard 9 as well as triangles that we have done in standard 9. See, as we know that whenever we need to prove that a quadrilateral is a rhombus or not, we have to prove that its four sides are equal to each other. So if four sides of a quadrilateral are equal, then we can say that it is a rhombus. Now, if we need to prove that the given quadrilateral is a square or not, then with the help of the property that when a rhombus has the equal diagonal, then it will be a square. So, if we need to prove that the given quadrilateral is a square or not, we have to prove that its four sides are equal, and with that its two diagonals are also equal. So, if four sides of quadrilateral and its two diagonals are also equal, then it is a square. In same way, if a quadrilateral has the opposite sides equal to each other, then it is a parallelogram. If a quadrilateral has its opposite sides equal to each other, it is a parallelogram. And if we need to prove that the quadrilateral is rectangle, in that case its opposite sides as well as its diagonals has to be equal, then only it is a rectangle. So if a quadrilateral have its opposite sides equal and its diagonals are also equal, then it is a rectangle. So these are some of the general rules to prove whether the given four vertices on a Cartesian plane are of rhombus or of square or of parallelogram or of a rectangle. So I am giving you example. Suppose it is given that the points A 0, -1, B 8, 3, B 6, 7 and C -2, 3. If we have to prove that these 4 points are the points or the vertices of a rectangle or not, we need to prove that its four opposite sides are equal or not. So here the figure is given. If the figure is not given, you will take the name continuously like A, B, C, D. But here since the figure is given, I am using the figure 0, -1. Here it is given D, that is 8, 3. Here it is given C 6, 7 and C -2, 3. So I think you have written this. So I am rubbing it so that I can explain you this question. So here I am making once again the big figure. See, here it is given A 0, -1, D 8, 3, B 6, 7 and C -2, 3. So dear student, if we have to prove that this quadrilateral is rectangle In that case, we need to prove that its opposite sides are equal. Means we have to prove that AD is equal to BC and AC is equals to BD. And with that, we also have to prove that its diagonals are also equal. Because if only the opposite sides are equal, in that case that quadrilateral is said to be a parallelogram. And to convert a parallelogram into rectangle, we need to prove that its diagonals are also equal. So here, to prove this, at first we will find the value or the length of all the sides. So at first I am finding AD. For AD, this point is x1, this is y1. So for AD, A 0 minus 1, D 8 3, this is x1, this is y1, this is x2, this is y2. So AD equals to 0 minus 8 whole square minus 1 minus 3 whole square, 64, 16. It is root under 80. Now I will find BC. So for BC, B is 6 7 and C is minus 2 3. So here x1 is this, y1 is this, x2 is this and y2 is this. So BC equals to root under 6 minus then minus 2 square, 7 minus 3 square. So it will be 64, 16, it is also 80. So as you can see that AD and BC are equal to each other. AD equals to BC is equals to 80 degree. In same way, when you will find the value of AC and BD, they will be also equal to each other, and the value of AC and BD will be root under 20. So since the opposite sides of this quadrilateral are equal, so we can say this is a parallelogram. But here we have to prove that it is a rectangle. So for that we have to find the value of its diagonal also. So for finding the diagonals are AB and DC. So when we will find AB, it will be root under 0 minus 6 square plus minus 1 minus 7 square, 36, 64, that is 10. And when we find the DC, it will be root under minus 2 minus 8 square, 3 minus 3 square, 100, 0, that is 10. So AB equals to DC. So dear student, since in this quadrilateral the opposite sides are equal as well as the diagonals are also equal, so it is a rectangle. So I hope this is clear to you that how with the help of distance formula we can prove that the given vertices are of the quadrilateral or are of the square or are of a rhombus and all. In same way, we will discuss for the different kinds of triangles also in the next video. Till that time, please write it down these things, and if you have any query, please comment it, please subscribe and share the channel. Thank you.